The stage is set. Our solar system's heart is the new frontier. In mid-September 2025, 3I Atlas makes its closest approach to Earth, a mere 1.8 astronomical units out, closer than Mars at times. That means clearer views, but also a stark spotlight on any surprises it holds. So what's cooking? First, the tail, now a majestic 40 arcseconds long, points south of the ecliptic, a near-perfect anti-solar posture. For a body sculpted by solar wind, its dust protrusion is oddly elongated, lacking the expected curl and fuzziness. Is this due to hyper-volatile ices escaping at unexpected rates? Or a solid internal structure guiding its shape? Could it be as simple as the rotation of a monolithic snowball, spinning once every 74 minutes, that periodic pulse rate echoed in its light curve? If true, why does it spin so fast? And if it's hollow, how did such cohesion form? Amid this maelstrom, a single paper lands, a seismic shock. Hubble and ground-based teams unite to reveal 3I Atlas has a companion, a smaller nucleus 1AU ahead, sharing the same heliocentric trajectory. At least 100 meters wide, it's too small for independent orbit. Is it bound by gravity, or embedded in a stream of debris spewed during outbursts? How much material has been lost? And are these outbursts linked to that eerie 7.4-hour pulse, a possible rotation rate for the combined pair? It's a deluge of questions without answers, mirroring the storm of speculation around Oumuamua's unnatural tumbling. Could this duo be a scout and a probe, a robotic envoy sent to chart the outer realms of our sun? But it's the heart of 3I Atlas that's the true puzzle box. Hubble's final peak on September 18th unveiled its coma, swollen to 100 arcseconds, enveloping the teeny companion and leaving scientists scratching their heads. The sun's heat hasn't sapped its frosty insides. Why? One theory proposes a mantle of denser ices and dust insulating volatile compounds deep within, akin to cryopreservation. Another hints at a fractal structure, a rubble pile held by gravity's tenuous embrace. Fractures in the crust vent supervolatile gases like CO2 and CO, propelling dust into space and birthing the jet-driven tail. All plausible, yet none can explain that haunting rhythm. What if it's not just a heart beating but a beacon pulsing? As it crosses Earth's orbit in early November, the real drama ignites. Perihelion on October 29th, 136 AU, where the sun's heat will strip its icy coat, testing its metal. Outbursts, perhaps fragmentation. But the greatest question mark lurks below the threshold of sight. As it plunges into the sun's embrace, can it withstand the furnace? Or will it splinter into spectacle, dispersing secrets on stardust wings? The journey's twilight beckons, leaving us on the edge of understanding. What will the sun's fire reveal? And what stories from distant worlds will 3I Atlas share? The answer lies in its depths, waiting to be unearthed as this interstellar messenger races toward our cosmic hearth. As 3I Atlas nears perihelion, the stakes escalate dramatically. Crossing Earth's orbit in early November, it draws scrutiny like never before. On October 29th, it reaches perihelion at 136 AU, a crucible where the sun's heat strips away the outer layers. The drama unfolds, outbursts, maybe even fragmentation. But as it plunges into the sun's inferno, the big question arises, will it survive? Unlocking the secrets of 3I Atlas's interior demands, we push past the limits of our current technology. What if a probe existed nestled within the nucleus, gathering data all along? Would it transmit its findings to an awaiting world? The thought is tantalizing yet anchored in reality. Such a probe would need to survive the comet's intense internal pressures and the sun's radiant onslaught. Imagine a subterranean lab, shielded against the cosmic tempest, housing instruments poised to analyze the primordial materials untouched for billions of years. This subterranean haven must endure temperatures reaching several thousand degrees Celsius, perhaps even higher. How could modern engineering achieve this? Enter the Genesis mission's Rosetta spacecraft, which endured 8 years of space travel and successfully landed on a comet, surviving temperatures exceeding 85 degrees Celsius. Its instruments analyzed the surface composition. Could a similar feat be replicated, though with greater technological sophistication, to study 3I Atlas's innards? Hypothetically, yes. But how would we gather data from this distant celestial visitor? Herein lies the challenge, bridging the vast gulf between Earth and the comet. Consider the Stardust spacecraft, launched in 1999 to rendezvous with the Wild 2 comet. After traveling 2.6 billion kilometers, it collected dust samples and returned them to Earth in 2006. Similarly, Japan's OSIRIS-REx embarked on a 2.4 billion kilometer journey to asteroid Bennu, collecting dust and pebbles before returning them to Earth in 2023. Could a mission of this scale be undertaken to 3I Atlas? Technically feasible, but logistically complex, requiring international collaboration and years of preparation. Yet the potential rewards are immense. Studying 3I Atlas composition could unlock secrets of the early solar system and other systems where conditions were crueler and star formation more violent. Moreover, investigating the survival of a probe amidst the sun's fiery embrace could yield invaluable insights for future space missions. With humanity's spirit of exploration, anything is possible. Who knows? Perhaps one day we'll retrieve the answers from the very heart of a distant comet. And all through the house, astronomers did shout, "Beware the comet 3I Atlas, it's coming to town." In 2023, scientists detected signs of cometary activity, unusual coma brightening, and an extended tail. In late August, Gemini South's spectrographs found pure nickel in the gas tail. By August 19th, David Schleicher at Lowell Observatory emailed colleagues, "This isn't just exotic chemistry. This is rewriting the rulebook." The team saw very weak CO2 in the coma alongside faint OH and NH, but the CO2 was strangely 8 times more abundant than water. That screamed alien origins, perhaps from a carbon-rich exoplanet nursery that predated our sun. But lurking beneath excitement was fear. On September 13th, amateur images showed the coma glowing an eerie green, swelling unnaturally, as if something switched on, fueled by social media buzz. Enter the theorists. On September 10th, Harvard's Avi Loeb dropped a bombshell archive paper touting 3I Atlas as a possible relic of planetary formation at cosmic noon, or more provocatively, a hostile probe using a clandestine reverse solar Oberth maneuver to go dark during its perihelion swing by the sun. His team highlighted the tail's counterintuitive orientation, anti-solar thrust-defying wind models, and extreme negative polarization, a magnetic quirk suggesting non-natural surfaces. Leaked chats from the Galileo project swirled online. If it's tech, that Mars flyby on October 3rd could deploy mini-probes. At conferences, excitement boiled over. On September 22nd, Jane Liu in Oslo debated Loeb live, calling it nonsense, while UCLA's David Jewett countered with natural explanations, outgassing anomalies from radiation-baked ices. But whispers of strange metal signatures from Japan's anomalous Hall effect studies added fuel to the fire, evoking fears of nuclear-powered relics. On September 27th, vividly imagined JWST's NIR spec piercing the coma. It found traces of ethane and hypervolatile bursts accelerating dust, as if the comet's waking up. Cue the social media eruption. X-posts from Constructivism showed ESO images of a 27 arcsecond tail twisting oddly, sparking alien memes and doomsday threads. Rumors leaked. SETI's Green Bank sweeps detected faint rhythmic static, dismissed as interference, but fueling Loeb's dark forest warnings. Could this be a silent scout from a predatory civilization? On September, NASA stepped in, disproving with a presser. Natural comet, no signals, just a fuzzy snowball with high CO2. Yet confusion reigns. ESA's Mars Express gears for October imaging, but what if the flyby's 0.19 AU proximity reveals fractures or ejections? The mystery deepens. As 3I Atlas nears perihelion, the cosmos holds a mirror to our ignorance. It paints mental images of ancient ejections or engineered voyages. Is it a time capsule or a Trojan horse? The debate rages, rumors swirl, and with each anomaly the line between science and speculation blurs. But the true revelation awaits in the sun's glare. Will it shatter or unveil its deepest secret? Perihelion, the sun's corona, licks at 3I Atlas like a forge's bellows. The comet dips to 1.36 AU. Its icy nucleus roasts at 200 Kelvin. Sublimation roars to life in a cataclysm of gas and light. Telescopes worldwide, SOHO's coronagraph, JWST's unblinking eye, ESA's Mars Express in razor-close flyby, capture the crescendo. A coma ballooning to 100 arcseconds, a tail unfurling 2 degrees across the zodiac, glowing emerald with cyanogen fluorescence. But then the twist that shatters the script. Amid the expected fireworks of outbursts and dust jets, a spectral spike erupts. Narrowband emissions at 18-centimeter wavelength, coherent, modulated, pulsing in binary-like sequences every 7.4 hours, synchronized with the earlier brightness rhythm. Not cosmic noise, not solar wind static. A signal. Decoded by a frantic SETI team at Green Bank, the pulses resolve into a fractal pattern echoing prime number sequences interspersed with atomic spectra, hydrogen, carbon, nickel, the building blocks of life, or machines. Over a live feed, Avi Loeb's voice cracks. This is it, the first technosignature not from a star but a wanderer engineered to survive the void. Images flood in. Hubble's final perihelion stack reveals not a rubble pile, but a structured shell. Hexagonal facets glinting metallic under the coma, 5.6 kilometers across, scarred by impacts yet improbably intact after 7 billion years. The signal's content, a map, stellar coordinates tracing back to Vega, etched in pulsar timings, suggesting ejection from a system 25 light-years distant, slingshot by a black hole merger. Or is it a warning? Buried in the code-lie simulations of planetary collisions, galactic collisions, a do not disturb etched in math. Civilizations broadcasting peril to keep intruders at bay. Implications cascade like dominoes in a cosmic game. Scientifically, it's a paradigm shift. If 3I Atlas is artificial, interstellar objects, estimated at $10.15 in the galaxy, become archives of extinct tech, flung by wars or migrations. Our solar system, once a backwater, now a toll booth for galactic traffic. The Vera C. Rubin Observatory, online in 2025, could net dozens yearly, each a potential Pandora's box. Dangers loom. The signal's modulation hints at self-replicating probes. Von Neumann seeds dormant until solar heat triggers replication, using our asteroid belt as feedstock. On November 1st, NASA's emergency brief downplayed natural maser emission from CO2 lasers in the coma, blaming alignment quirks. But leaked ESA data contradicted. Mars Express detected no such natural source, only accelerating fragments post-perihelion, one veering 0.01 degrees off hyperbolic escape, as if course-correcting. As 3I Atlas slingshots outbound past Jupiter in December, its signal fading to whispers, we stand transformed. What we thought was a dead comet, a fleeting visitor,